Hello, awesome Algebra 1 students, and welcome back to your video notes. If you are absent in these weird COVID years, you can use these videos to stay caught up. This is our second lesson of the year, and it's still in our first topic, which is all about solving equations and inequalities. We're just going to focus on equations today. Let's go through and see what we're doing. Well, the title of our lesson is Solving Linear Equations, and we'll explain more what linear means later on. And we're going to focus on using distributive property today. So, last class we learned how to solve one- and two-step equations. And to solve those equations, we used the acronym SADMAP, which was PEMDAS backwards. And what that told us is the first thing you do is you look at the values or the numbers that are attached to x, and you say any ones that are using addition and subtraction, you undo them by using the inverse operation. Addition, you do subtraction, vice versa. Then once you've undone all the addition and subtraction, you move on to multiplication and division. If you see any division, undo it with multiplication, vice versa. And then I mentioned that technically to continue PEMDAS backwards, we have exponents and parentheses, but we're not really dealing with that this semester. So for today, I'm just going to write this order, and we should know that we work from the top down, and it tells us how best to isolate x. Now the nice part about today is it's really just a quick extension on what we did last class. So if last class you're like, well, I'm kind of getting the idea, but I'm still a little stuck here and there, then today's going to be perfect for you because we're only going to add one extra step and you're still going to get to focus on that SADMAP part of isolating. So what is our extra step? Well, sometimes before you start to isolate the variable, it's going to be useful for you to simplify each side of the equation first. Doing a little work up front will save you some extra work at the end. Now when I say simplify, these are what we called last class properties of expressions. We're not going to do something to both sides. We're going to look at each side separately and simplify each side separately. So what are the only two things for simplification that you need to remember? Well, the first is that we will probably have to distribute. Now, when you distribute, we are usually distributing multiplication and division. And the giveaway that we're distributing multiplication and division is if we have parentheses. And that's what I just drew up above. These are parentheses. The second thing we might have to do is, and I bet you'll know this one, we may have to combine like terms. I like to do them in this order as well. I like to try distributing first. I'll put a little 1 next to it, and then combining like terms second. Now we won't have to do both of these every time. We may not have to do either of them. Last class we didn't do either, but sometimes you may do both, sometimes maybe just one. So what I have here are really 9 practice problems, and they kind of build, I think, from easiest to hardest. And if you're feeling comfortable with this, if you're like, I totally know how to do this, then please work on ahead. Don't wait for me. I'm going to be slower than you. However, after you try a problem, if you get super stuck and you're like, I'm not understanding where to start, then unpause the video, watch the part where you're stuck on, then finish off the problem and move on. Please, please, please don't listen to me explain how to do every single problem. That just takes too long. All right, let's begin. So, go ahead and pause the video, try the first problem. We'll see how you do. If you get stuck, come back and definitely listen to my explanation. Ready, set, go. Okay, you're back. Well, when I work through these, again, I'm going to follow 3 steps. First is distributive property, second is combining like terms, and last but not least, I'm going to work through SADMAP. And remember, I'm leaving off the E and the P to decide how best to isolate x. So, distributive property. The question you need to ask yourself is, are there any parentheses here? Nope. So we're probably not distributing multiplication and division. We move on to step 2, like terms. Well, if we look at just the right side of the equal sign, that's just 12. It's not going to combine with anything there. What about the left side of the equal sign? Well, I think I do see some like terms here. I see 3 x's here, and then what coefficient is hiding in front? Oh yeah, that's that 1 that's multiplying. Remember, these numbers in front of variables that are attached by multiplication are known as coefficients. Coefficients count the number of the variable there. So for example, in this case I have 1x, and I'm adding on 3 more x's. So if you have 1 of something and you add 3 more on, that's going to give you 4 of those x's. And then the right side, don't forget, still is an equals 12. Now we've undone distributive property. there wasn't any. We've combined our like terms, so now we're down to SADMAP. All right, we look and say, well, what number is attached to x? Well, the 4 is the only number attached, and the 4 looks like it's right next to the x, so it's attached by multiplication. To undo multiplication, we use its inverse operation, which is division. That means we divide both sides by 4. Any number divided by itself always makes a 1, so we have 1 times x, but we don't need to write a 1 if it's multiplying, so that just leaves us with x alone. 12 divided by 4 is 3. And we're set. Distribute, combine like terms, SADMAP. That's it, and that's really going to be it every day for the next couple days. So as before, if you're feeling comfortable, please work on faster than I'm going. You can just play this video at 2 times speed if you want to see the right answers, or you can always pause it and slow it back down to real time if you need an explanation. So problem 2. Problem 2 does have parentheses, which means we're going to start with that distributive property. When we distribute, this is 3 times, we take the number that's either multiplying or dividing to the parentheses, and we distribute that number inside. So in this case, I'm going to go ahead and take the 3 and distribute it to the x, and I am also going to take the 3 and distribute it to the negative 2. Please don't forget that there is an invisible 1 in front of the x. So when I do 3 times 1x, that just gives me 3x's. 3 times negative 2 is negative 6 equals 10. All right, we've undone distributive property. Now we look to combine like terms. Do you see any like terms on the right side? Oh no, it's just 10. Any like terms on the left side? No, the 3 has an x attached to it. The 6 doesn't. They are not like terms. So we're on to that SADMAP part. All right, what are we going to undo first? Well, there are 2 numbers attached to x. 3 is multiplying. 6 is subtracting. In SADMAP, I think addition and subtraction comes first, so we should undo subtracting 6. Now, last class I used the horizontal method, so last class I would have grouped this in parentheses and put a plus 6 here. This class, though, I wanted to show you probably the more common method, the vertical method for solving, and then you can choose which method you prefer. So, to undo this, I'm going to add 6, don't forget to each side of the equal sign. Negative 6 plus 6 is 0. That gives me 3 times x equals 16. Now we're on the multiplication and division piece because I see the 3 still attached to x by multiplication. Well, we undo that by dividing by 3. And I have good and bad news for you. 16 divided by 3, 3 doesn't go nicely into 16. But that's good news because if you ever get a fraction, and that's what this is, 16 divided by 3 is a fraction. If you get a fraction where the denominator doesn't go nicely into the numerator, in Algebra 1, you get to stop. That's your answer. And that's awesome. Less work. Now, some of you might be saying, whoa, I prefer decimals to fractions. I'm going to make that a decimal. Great, that's totally fine. You will get full credit. To turn it into a decimal, you'll probably want a calculator available. You're going to do 16 and divide that by 3, right? We read from top to bottom. 16 divided by 3, you'll find it is 5.3 repeating. And so we use that little bar to show the repeating 3's. All right, moving on. Remember, at any time, zoom off ahead. 4 equals negative, parentheses, negative x plus 3. We need to go through and try to simplify. We start with distributive property. I do see parentheses. The question we have to ask ourselves is what number is multiplying or dividing to the parentheses? I only see a negative here, but multiplication and division, we should know there can always be a 1 hiding. So this negative 1 is multiplying to the parentheses. How do we do that? Well, we take the negative 1 and we multiply it to the negative 1x, and we take the negative 1 and we multiply it to the positive 3. 4 stays the same. Negative 1 times negative 1 is positive 1, and the x just tags along. Negative 1 times positive 3 is negative 3. All right, SADMAP time. We can see, I keep writing that backwards, whoops. We can see there are 2 numbers attached to x. 1 is multiplying, 3 is subtracting. Addition and subtraction go first, so I'm going to undo subtraction with addition by adding 3 to each side. 4 plus 3 gives us 7, and then there still is a 1 attached to x by multiplication. You might say, oh, multiplication, we can undo that with division, and you're right, but we can actually be even faster. Because remember, if you're doing 1 times something, do we really need to write the 1? right? If you had $10 and I said, ooh, I'm going to give you 1 times your $10. You're like, but 1 times $10 is $10. That's how much I already have. And I'd say, ha, you're right. I'm a teacher and I don't have that much money. So we don't actually need to put the times 1 because it keeps everything the same when you multiply by 1. And so we find 7 equals x. Sometimes students say, well, wait, 7 equals x. I thought we were supposed to do x on the left side equals 7. Can we do that? Sure you can. Either one is fine. All right, 4th problem. We should be getting the hang of things. This is going to put everything together. First step, distributive property. We need to distribute the 4 to the 2x and distribute the 4, if my pen color would change, there we go, to the 3. 4 times 2x is 8x. 4 times 3 is 12, and then we still have the plus 1 and equal to 13. From here you have a couple options. Some of my students said, oh, I'm just going to subtract 1 from both sides and subtract 12. Can we do that? Yeah, you can actually do algebra in any order. It doesn't matter as long as you do the rules correctly. So if you want to subtract 1 from both sides, do it as long as you do it from both sides. I'm going to go ahead, though, and show you my most efficient steps, the ones that I do it. You don't have to do it this way. So after distributive property, we also need to check for combining like terms, and I think there are some like terms up here. On the right side, there's no like terms, there's just 13. But on the left side, there are some like terms. In particular, I see 12 plus 1 more. So that's going to give us 8x plus 13. And that is equal to whatever is still on the right side, which seems to be 13. All right, SADMAP time. 2 numbers are attached to x. 8 is multiplying, 13 is adding. SADMAP says undo addition and subtraction first, so we can do that. And we end up with 8 times x equals, well, 13 minus 13 was 0, so I didn't write anything. But this side is also 13 minus 13. And that is also 0. So can I just not write anything? Well, it's kind of like fractions. There's nothing on top of a fraction. We don't leave it blank. We put a 1 as a placeholder. So we do always want to have a number on each side. And in this case, 13 minus 13 is 0. So I am going to write the 0. All right, 1 step to go. There is still 1 number attached to x, and that is the 8. The 8 is multiplying. To undo multiplication, we need to divide. Anything divided by itself is 1, and we don't need to write the 1, so we get x equals 0 divided by 8. Well, if you had $0 and split that amongst 8 friends, how much would each person get? Well, they'd probably get annoyed because each person would receive $0. Don't forget that 0 is a number. 0 divided by anything is 0. Moving on through. 7x minus 3 minus 5x plus 2 equals 0. There is no distributive property because I don't see parentheses. There probably are some like terms, though. In particular, we have this 7x, and then notice how I'm going to box this over here. I'm going to include that negative sign in front because we want to know what type of number it is, positive or negative. When you have 7 of something and you take away 5 of something, I believe that gives us 2 of something. Then, when we have negative 3, see those signs, plus 2. Negative 3 plus 2 is negative 1. And then this all still equals 0. SADMAP time. We undo addition and subtraction by adding 1 to each side. That leaves us with 2x equals 1. There is still a number attached to x by multiplication, so we're going to undo the multiplication by, of course, division. 2 does not go nicely into 1, so we end up with the fraction 1/2, and that's fine for an answer. If you really felt the need, you could do $1 divided into 2 equal parts is 0.5, and that's okay too. Problem 6. Hopefully we're getting used to looking for those distributive property and like terms at the beginning. This one's a little tricky though because this says 5 minus. Distributive property only works if we have multiplication or division that's distributing. We don't distribute addition and subtraction. But we can't just drop the parentheses here. There is something multiplying times the outside of the parentheses. And when nothing's there with multiplication, we always know it's an invisible 1. So in this case, the 5 is not distributing. 31's minding its own business. It's the negative 1 that needs to distribute to the x and to the 2. Negative 1 times 1x is negative 1x. Negative 1 times 2 is minus 2. We have now distributed. The next question we need to ask is, are there any like terms? Well, I see a 5 and a minus 2. Remember, we ignore the 31. It's on the other side. It's all by itself. 5 minus 2 will give us 3. And then there is still a minus 1x equals 31. Now, quick trick of the trade, since I've taught this class a few times before, my students really like putting the x's first, so I'm going to switch the order. I'm going to put the negative 1x first, and then this 3 is a positive 3, so I'm going to put that second. I didn't do any algebra there. I just used one of our properties to rewrite the equation. Now, SADMAP. Undo addition and subtraction first. It looks to me like there are 2 numbers attached to x, negative 1 multiplying, 3 adding. So let's undo adding 3 by subtracting 3. This becomes negative 1 times x. 31 minus 3 is 30, 29, 28. Negative 1 is multiplying times x, so we should probably undo that with division. And that leaves me with x equals, well, anything divided by 1 is itself, but a positive divided by a negative, oh, that's right, that's a negative, isn't it? And so we end up here. You can always use your calculator to double check these answers, or if you're not sure about positives or negatives, it's not a bad thing to check. However, you also will probably want to make sure you can do this by hand, because you can't be guaranteed you'll be allowed a calculator on each test. All right, let's move on. 3 to go. Really, at this point, you should be able to do all the rest of these without my help. So I hope that you pause this, do the rest so that you can skip forward faster. But if you want to listen to my wonderful voice continue to guide you through, you can. All right, step 1, distributive property. The 2 has to distribute or multiply to x minus 1. That gives us 2x minus 2. 3 has to distribute to the 4 and to the negative 1x. So that's positive 12. And negative 3x equals negative 1. We did the distributive property. What's next? Oh yeah, combining like terms. So let's take a peek. We have 2x's and minus 3x's. 2 of something minus 3 more gives us negative 1 of those things. Then we have negative 2 plus 12. 12 minus 2 is 10. And the right side has not changed. It's equal to negative 1. SADMAP time. Hopefully you're getting used to hearing this, and you might even wince each time. You're like, okay, I know it's SADMAP. Stop telling me. The more I tell you, the better you're going to remember. So negative 1 is multiplying, 10 is adding. We undo addition first, so we better subtract 10 from each side. Okay. This leaves me with negative 1x, and on the right side, negative 1 minus 10 more is negative 11. We're almost done, but we need to get rid of that negative 1, so we should probably go through and divide it off as it's multiplying by x. This makes 1. It leaves us with x equals a positive divided by a negative divided by a negative is a positive. Anything divided by 1 is itself. All right, 2 to go. Here comes problem 8. Problem 8, I see a lot of like terms on here, and in fact, we're going to do each side. Now, one mistake I see students make with like terms is that oftentimes they go through and they think, ooh, we're going to do the 5 and the minus 1 and the 3 and the 1 and the 1. Like terms can only be combined on each side of the equation. So let's ignore everything over here and think, what are my like terms? Well, they're all like terms, I think. They're all like terms, and we can just combine from left to right. 5 minus 1 is 4. 4 plus 3, all of these just become 7. Very nice. And now we do the right side. To do the right side, we have this 1x and another x and another x. 1 of something plus another gives us 3 of those things. And then we have 1 plus 1 more, which is 2. Looks pretty good. We are just about done. Now that we've combined our like terms, all we need to do is isolate x. X is on the right side. We just need to follow our friendly SAD map that we've been doing all day, and hopefully you're comfortable with this at this point, subtracting 2 from each side. That leaves us with 5 equal to 3 times x. And from here, dividing off the 3. 3 doesn't go nicely into 5, so we're allowed to keep this as our final answer. If you would like this as a decimal, you should end up with 1 and then 6 is repeating, 1 2/3 if you'd like. And that's it. The problems really do tend to get faster the more comfortable you are. Combine like terms, add, subtract, multiply, divide, the end. And it's the same steps every time. So let's move on to our 9th problem, which can be somewhat intimidating to look at just because of those scary F-word fractions up there. But we're going to see this in a different light, and I think you'll be confident after the fact. We're going to take 1/2 and distribute it to the 8x and to the 4. And instead of thinking 1/2 times 8x, think of half of 8x. Half of 8x is 4x. Half of 4 is 2. Really, multiplying by a half just means divide those numbers inside by 2. And if that's the case, when I distribute my negative 1/3, what am I really dividing by? Oh yeah, just 3. 1/3 of 3x is 1x, because 3 divided by 3 is 1. A negative times a positive is a negative. 1/3 of 9 is 3. A negative times a positive is a negative. And we end up here. Once we're here, same steps as before we distributed, we should probably combine some like terms. I see 4x taking away 1x, which will give us, of course, 3x's. I also see 2 taking away 3, which will give us -1. And that is, of course, equal to 17. SAD map time, same side as x. Add or subtract first, so we should probably add 1 to each side. 3x equals 18. Last step, undo the multiplication with division. And 18 divided by 3. 3 does go in nicely this time. We will divide it. It gives us 6. Okay, well, we've taken care of these 9 problems. And honestly, if you're feeling somewhat comfortable with these, you've really grasped the lesson. The rest of this video goes on to teach you some extra types of problems. For example, this is a very common word problem that we're about to work through. And then on the next couple pages, we just see some different ways to solve equations instead of just a single equation. So, let's get to it. Word problems are an integral part of algebra. What does it mean if something's an integral part? It's an extremely important integrated part of algebra. It's locked in there. You can't do algebra without doing word problems. So let's look at the problem. It is given that the sum, what does it mean if you sum up numbers? And you add them, don't you? The sum of 3 consecutive numbers is 132. Well, what are 3 consecutive numbers? I can give you a few examples. 1, 2, 3 are 3 consecutive numbers. 17, 18, 19 are 3 consecutive numbers. Think 3 consecutive numbers. My students most often say consecutive means one after another. One right after another. 3 in a row, if you will. So we're trying to find the sum of the 3 numbers that add up to 132. Well, could it be 1, 2, and 3? Well, I don't think so. 1 plus 2 is 3. 3 plus 3 is 6. 1 plus 2 plus 3 equals 6, not 132. It has to be a lot larger than 1 plus 2 plus 3. So do we just guess? Do we just add up any numbers we want, like 30, 31, and 32? 50, 51, and 52? What's it going to be? Well, this is where algebra comes in handy. Algebra is going to give us the tools that we need to solve this equation. But if we're going to solve an equation, we probably need to write an equation first. So let's start with words. Always easier to start with words. Write an equation to model the scenario of one of those numbers, those consecutive numbers, is x. Well, we have our first number plus our second number plus our third number. We're summing 3 consecutive numbers, and we know the sum is 132. one of those numbers is going to be x. They can't all be x. That would mean they're all the same number. It's pretty common to just pick the first number to be x. And because I'm substituting, I'm going to use parentheses to show that x stands in for my first number. But if x is just my first number, what do we use to stand in for our second number? Well, imagine x was 4. What's the next number if these have to be 3 consecutive numbers? 4 and then 5. How much larger is 5 than 4? Well, it's whatever that number is plus 1. If this is 4, then we add 1 to get 5. And in the same vein, how would we write the third number? Well, if this is 4, this is 5, this is 6, how much larger is 6 than 4? Well, it is 2 larger. This will always work for consecutive numbers. If x was 10, then 10 plus 1 is 11. 10 plus 2 is 12. 10, 11, 12, 3 consecutive numbers equals 132. Now we have an equation. Part B asks us to find the value of x. Well, in order to do that, we know, of course, that we need to drop parentheses. Whenever we see parentheses, we're thinking distributive property. But if there are 1s in front of these, those invisible 1s, and you distribute a 1 to each set of parentheses, does multiplying by 1 change the number inside? No. So actually, in this case, if you just have 1s, you can drop all of your parentheses and write our equation without. So now instead of distributive property, I think we just need to combine like terms, don't we? X plus x plus x, these all have 1s. 1x plus 2x, or 1x plus another gives us 3x's. Then 1 plus 2 gives us 3, and that's equal to 132. All right, we've done distributive property and combining like terms. I think it's SADMAP time. Undo addition or subtraction first. Leaves us with 3x equals 132 minus 3. Minus 2 is 130, minus 1 more is 129. There we go. All right, and then last but not least, we undo the multiplication. Anything divided by itself is 1. This looks intimidating at first, but let's do it in pieces. 3 goes into 12 4 times, and there's nothing left over. So then we look 3 into 9, and that goes 3 times. X is equal to 43. Well, do we solve the problem? They want to know what the 3 consecutive integers are. I just found x. I just found the first number. So we know it's 43. What are the other 2? Oh, they're consecutive. 44 and 45. Is this the right answer? Well, it's pretty easy to check. Take out those calculators and try 43 plus 44 plus 45. And guess what? You get 132. Check, smiley face, look at us. All right, we've got the hard stuff done. Let's get to the cool stuff. First things first, we need to remember that there's no one correct way to solve an equation. For example, let's look at this kind of complicated equation here. Mr. Grant does something to both sides for his first step. When he simplifies, he goes somehow, that crazy guy, from here to here. What does he do? Well, it looks to me like this 2 times x plus 4 is still there, but this divided by 3 isn't. This 8 became a 24. This 32 became a 96. What does it look like everything was multiplied by? I think I undid dividing by 3 by multiplying by 3. And here's what this looks like, and it's a very important step to pay attention to. 2 times x plus 4 divided by 3 minus 8 equals 32. I said I don't like this divided by 3, so I'm going to take this whole side and multiply by 3. Because remember, whenever you do something to a side, you have to do it to the whole side. Same thing over here. Well, when you multiply by 3, I see 2 terms inside, one term and a second term. So if I distribute the 3 to this first term, it's going to undo the dividing by 3 and just leave me with 2 times x plus 4. When I distribute the 3 to the second term, that's just negative 24. And on the right side, of course, 3 times 32, 3 times 3 is 9, 3 times 2 is 6. Let's finish solving this. Well, now we're back to our usual steps. Distributive property first. 2x plus 8 minus 24 equals 96. Combine our like terms. 8 minus 24 is negative 16. And now it's SADMAP time. Add 16 to each side. 2x equals, let's see, 6 plus 6 is 12. It's 100 plus the 1 is 112. Last but not least, divide by 2. Okay, this one's a little harder. 2 goes into 11 5 times, but there's a remainder of 1. So then we need to do 2 into 12, which is 6 times. X equals 56. All right, now we solved the problem one way, but maybe there's a different way. Let's see how Miss Foley tackles this problem. She starts here, and then somehow she goes from here to here. Well, what's different? It looks like that minus 8 vanished. Well, we can undo subtracting 8 by adding 8. Now, I want to show you something similar to what we did up above, and I'm going to get rid of all these extra pieces here so we can see these parentheses that are going on. I grouped this in parentheses and said times 3. So I'm going to do the same thing here just so you can see the similarities yet differences. I'm going to group this in parentheses, so let's use color, and I'm going to go ahead and add 8. Same thing on the other side, 32, I'm going to add 8. Now we learned on one of the very first days of this class that when you add or subtract to both sides, it does not happen to everything in the parentheses, only to its like term, only to one of the terms there. So negative 8 plus 8 cancels, and this guy stays the same. Unlike multiplication, where I had to distribute the 3 to both terms inside, when you add or subtract, it only goes to one of the terms. And then 32 plus 8 is, of course, 40. So we added 8 to each side. What next? Well, next we have this divided by 3 here that I don't see anymore. So I think next we probably took both sides and did times 3. Cancels out the dividing by 3. 40 times 3 is 120. And then we're looking pretty good. All right, let's go ahead and solve. Solve 2 times x plus 4 equals 120. Well, I see some distributive property. 2x plus 8 equals 120. And then maybe some SADMAP to finish this off. Subtract that 8 from each side. 2x equals, I think that's 112. And oh, hey, we did this up above. Isn't this just x equals 56 from before? Cool. We solved it just in a different way. All right, let's look at our third and last method to solve this problem. Our third and last method, Miss Harvey is going to demonstrate for us. And instead of treating the problem as 2 times x plus 4 divided by 3, she realizes that that's the same thing as 1/3 times, and I'll write this as a fraction, 2 times x plus 4 over 1. If you multiply straight across, that gets you here. And in fact, that's actually the same thing as 2/3 times x plus 4 over 1. If you multiply straight across, you get here. So if those are all the same, then we could actually, if this is over 1, rewrite this as 2/3 times x plus 4. So let's see what that looks like. She has rewritten the problem as 2/3 times x plus 4 minus 8. And Miss Harvey decides, instead of undoing SADMAP, I would probably add 8 to both sides first, or maybe distribute. She says, nah, I want to get rid of the fraction. And I know to get rid of fractions, we can use a reciprocal. And she's right, because you can go out of order of SADMAP. You are allowed to. It's not always the most efficient, but as you learn tips and tricks, you might find that you would prefer to do it this way. You just have to make sure that you group each side correctly and you'll be okay. Whenever you do something to both sides, group it in parentheses so you don't make mistakes. By putting parentheses here, you will see that you need to distribute 2/3 to this whole term, and, 3 halves to this guy. Well, let's tackle the first term. 3/2 is going to cancel out the 2/3, and that's just going to leave us with x plus 4, no parentheses needed, x plus 4, and that's it, right? 3/2 cancels the 2/3, right? It's the reciprocal of 2/3. To do 3/2 times 8, I'll do that over here really quickly just so we can see the math. 3/2 times 8, or 8 over 1, just go straight across. 3 times 8 is 24, 2 times 1 is 2, 24 over 2 is 12. So 3/2 of 8 ends up being minus 12. On the right side, let's go over 1. 32 times 3 is 96. 2 times 1 is 2. And 96 over 2, this one's a little bit harder. Think of 100 divided by 2. 100 divided by 2 is 50. So I think 96 divided by 2 will probably be 48. Yeah, that makes sense. 8 plus 8 is 16. So we end up with 48. Let's finish this off. I don't see any more distributive property, but we can combine like terms. 4 minus 12 is 8. And there's only one step to go. Add our 8 to each side. And that ends with x equals 56. That's the same answer as all the rest. So the question becomes, which way did you like most to do this problem? Because there are many different ways to do the problem. I'm not saying any one way is correct or easier than another. It's totally up to you. I've found in the past most people prefer Miss Foley's method, where they add 8, multiply by 3, and then finish solving. That actually tends to be one of the longer methods, but it's a little more straightforward. Okay, almost done for the day. Let's look at some shortcuts. Fractions and decimals can be a little scary. However, we have some tricks that we've learned in the past that we can kind of tie together to this math to make our lives easier. For example, if you had 0.1 plus 2.3x equals 4.7, you might look at that and go, oh no, I'm not dealing with decimals. I don't like it. I'm skipping the problem. Well, I'm here to tell you today that you don't have to skip it. You can just get rid of the decimals at the beginning, because you learned a number both in science and math in middle school that you can multiply by that causes decimal points to move. Right? In particular, you learned that if you were to take this equation and you were to multiply by a specific number, you would move the decimal places 1 to the right. And you might be remembering that that number is 10. If you multiply by 10, it moves every decimal 1 to the right. So this becomes 0, 1 and a decimal plus 23 and a decimal equals 47 and a decimal. But we learned in the past, if you have a decimal at the end of numbers and nothing past it, you don't even need to write the decimal. And we also remove, we call these leading zeros, that 0 there. All right. Well, now we have an equation with no decimals. 1 plus 23x equals 47. We can solve this. Subtract 1 from each side. 23x equals 46. Divide by 23. And you'll find that 46 by 23 is 2. Now, some of you might say, well, I was fine with the decimal. I just subtracted 0.1 to get 4.6 divided by 2.3. My decimal game was strong. I got the answer. Good. That's great. You do not have to do this trick. It's just for those of you that maybe don't like decimals or want a different way to approach it. That's what it's for. So let's look at one more. Part B. 1/2 x plus 1/4 equals 3/4. Ooh, fraction. Scary, scary. Well, I'm here to tell you that a trick you've used with adding fractions for a long time can actually make your life a little bit easier. And that trick is common denominators. Looking at part B, can you see a common denominator that all three fractions would have their denominators go into? I always like the least common denominator because they do all go into 8, but I think they also all go into 4. 4 already. How do we turn that to 4? Well, we multiply by 2. They all have a common denominator, least common denominator of 4. So what I'm going to do is not actually give them a common denominator. I'm going to use that in my trick. So I'm going to go through and multiply each side by the common denominator. So I'm going to multiply each side times 4, which is the least common denominator here. And I'll start with the right side. 3 divided by 4 times 4. What happens when you have times 4 divided by 4? They make a 1, they cancel, and that leaves us with 3. We have a 4 on this side. We need to distribute the 4 to both of these. What's half of 4? Half of 4 is 2. Don't forget the x. Well, I'm distributing the 4 to the 1/4, and I see a times 4 and a divided by 4. And I think that just leaves me with 1. So in fact, this scary fraction problem, just by multiplying by the common denominator, and I'll notate that so you can see where that came from, multiplying by the common denominator allows us to eliminate all of the fractions. Now I just have 2x plus 1 equals 3. Now we have SADMAP. Subtract 1 from each side. This gives us 2x equals 2. Divide both sides by 2. And we end up with x equals 1. Nothing bad at all. All right, the last page of this packet is designed to be done with a partner. However, you do not have to do it with a partner. There are 3 problems here, and you should get the same answer every single time. I'm going to show the starting for A and B, and then I'm going to work all the way through C. You should try to solve all 3. We're going to work the same problem every time, though. And so what that means is you should get the same answer every time. So, problem. -2 times the quantity x minus 1 minus 6 equals 10. I don't have as much room here, so I'm actually going to do the horizontal method, where this one says we should add 6 to both sides first. So I'm going to group the whole side and add 6, group and add 6. -2 times x minus 1, -6 plus 6 is 0, equals 16. And then it says solve the problem any way you'd like. I'd probably distribute. Person 2 should distribute the -2 first. Okay, well we can do that. -2 times x minus 1 minus 6 equals 10. Distributing the -2 is -2x, negative times negative, positive 2, minus 6 equals 10. And go from there. I'd probably combine like terms. The last one, though, I wanted to look at because it's a little different than anything we've done today. The last one is suggesting that we should take this same problem. There's missing a negative up here, awkward. This -2 times x minus 1 minus 6 and equal to 10 on this side. And they're saying we want you to divide all of this by -2. Divide by -2. The right side isn't bad. 10 divided by -2 is -5. Don't know where my fraction line went. The left side is trickier, though. And the left side is trickier because, like multiplication, we have to distribute our division. This -2 is going to divide this term, and then it's going to divide the -6. Let's do the -6 first. -6 divided by -2 is +3. -2 times x minus 1 divided by -2, I'm just going to divide the coefficients on the outside because the parentheses are really kind of protecting that x minus 1. The -2 will get distributed eventually, so if we divide it at the beginning, whatever this answer will be will get distributed to the rest eventually. -2 divided by -2 is +1, and then this is just x minus 1. In fact, if there's a +1 and you distribute that, I don't even think that's going to change. I think this problem is x minus 1 plus 3 equals -5. The last part isn't bad for this. Combine your like terms, right? -1 and +3 gives us +2 equals -5. And finish solving by subtracting 2 from each side. We end up with x equals -7, and we're set. You should get -7 for these other two as well. They are not bad at all. All right, last couple problems on here. Shouldn't be too terrible. There's some fractions, some decimals. We're going to work through each of them a little bit quicker, and then we should be done. Okay, part A. 2 consecutive numbers, x and x plus 1, add up to 48. Show how to find the two numbers using algebra. Well, our first number is x. Our second number is x plus 1, and they sum up to 48. We discussed before the parentheses have 1 in front. We can just drop them. So I have 1x plus another x plus 1 equals to 48. Combine your like terms to get 2x plus 1 equals 48. Okay? We're going to go ahead and subtract this off. Something like this. And this gives me 2x equals 47. Finishing solving, we're going to divide by 2. And that gives me x equals, this gives me x equals 23.5. Well, part of math is making sure that your answers are reasonable. We were able to set up the problem as labeled and try to solve, but we got an answer that didn't make sense, because when they say two consecutive numbers, they probably meant two consecutive integers. This is not an integer, it has a decimal. And so what that means is that there aren't two consecutive numbers that add up to 48. 23 plus 24 is really close, 24, but that's 47. 24 and 25 adds up to 49. Two consecutive numbers will always add up to an odd number. This is even. So we did a problem where the setup was good, but the answer didn't make sense. Now you could argue, well, it's 23.5 plus 24.5. And you're right, that does work. So if you wanted to argue this way, great. If you wanted to say there are no integers, that is good as well. Let's try 4 consecutive numbers. Wonder if this is going to end up being an odd number as well. I think it will, but let's try it. So we have x, first number, x plus 1 is the second number, x plus 2 is the third number, and 3 larger than x is the fourth, and that equals 46. Combining all our terms, 1x, 2x, 3x, I have 4 x's, 3, 4, 5, 6, plus 6 equals 46. Oh, not 6. Sorry, 5. 1 plus 2 is, no, that's 6. 6, 6, 6, 6. Perfect. Okay, let's see if this works out. We're going to subtract 6 from each side. 4x equals, let's see, 46 minus 6, that's 40. I think this one's going to work out really nicely. Divide by 4. 40 divided by 4 is 10. Awesome. So what are the 4 consecutive numbers? 10, 11, 12, and 13 will sum up to 46. And I guess that should make sense. This is an odd number. We saw that before. This will also be an odd number. An odd plus an odd is an even. Okay, let's look at part C. Ooh, decimal. I don't like it. So I see part C over here has a decimal. We have 0.2 times x plus 3 equals 10. Let's use our newfound knowledge to make the decimal go away. I'm going to multiply this entire side by 10, and I'll do the same on the other side. This is all one term. I'm just going to distribute the 10 to the coefficient on the outside. It's going to move the decimal 1 over and give me 2. Inside of the parentheses stay the same. I'll have to change colors here. There we go. And the right side, 10 times 10 is 100. All right. Let's follow our distributive property. This gives us 2x plus 6 equals 100. And then SADMAP. Subtract 6. 2x equals 94. And divide by 2. X equals, let's see, 90 divided by 2 is 45. 46, I think 47, because 7 and 7 makes 14. That looks pretty good. All right, 3 problems to go. We're doing super well. Oof, more decimals. Don't like these at all. I think in order to make these decimals go away, don't we have to move it twice? So I think to move something twice, a decimal twice, instead of multiplying by 10, we multiply by 10 and then by 10 again, or we multiply by 100. So I'm going to take all of this and multiply times 100. Take this and also multiply by 100. When we do that, it's going to cause this decimal to shift 2 to the right, 2 to the right, and then this 5 has a decimal here. It's going to go 2 to the right as well, 2 more zeros. 13 has a decimal here, 2 to the right, 1300. Okay, what do we have? 103x plus 397x minus 500 equals 1,300. Holy Toledo. Well, I think that'll work. It'll be okay. But here's something else that I'm noticing. What if instead of multiplying by 100, I just combined like terms right away? 1.03x plus 3.97x. 0.03, 3 cents and 97 cents. Isn't that $1? 1 and 3 makes 4, plus the other dollar that's here. I think combining those like terms is just going to give me $5. And then the rest tags along. Minus 5 equals 13. Ha! I didn't even need to multiply by anything here. Just by combining like terms, it got rid of the decimals. Now, can you do it this way? Sure, it'll work just fine. But don't forget that some decimals aren't too bad. Let's finish off the problem. Add 4 to each side. By 4, I meant 5, but I decided 4 was the right thing to do. Add 5 to each side. 5x equals 18. And then, of course, divide by 5. Dividing by 5 here doesn't give us a nice answer. 5 doesn't go nicely into 18, so you can stop there if you would like. If you wanted to go further, okay, you could say that if you're really bold that this is 3 3/5 or 3.6. Any of those are acceptable as an answer. They are all correct. 2 to go. Ooh, fractions. 1/3. Oh, they already have a common denominator. Oh, this one's going to be a piece of cake. 1/3 x minus 4/3 equals 8/3. If all the fractions have a common denominator, multiply both sides by the common denominator. Here's why. On the right side, 3 times will undo the dividing by 3 and leave you with 8. When you distribute the 3 over here, multiplying by 3 will cancel the dividing by 3. When you distribute the 3 over here, multiplying by 3 will cancel the dividing by 3. And that just leaves us with 1x from the first fraction minus 4 equals 8. All right, let's add 4 to each side. That's our SADMET process. And instead of 1x, we know we can leave the 1 off. That's just x equals 12. Awesome. Okay, last but not least, this guy over here. Well, what do we want to do? There are a couple ways to approach this. You could distribute the negative 1/2 first. I think a nice trick, though, I noticed that this is 0.5. Anytime you double a 0.5, it becomes a whole number, right? If you double 50 cents, it becomes $1. And if I were to double a half, it would become a whole number as well. So I think what I'm going to do here is I'm going to take all of this, and I'm going to double each side. I'm going to take the left side and say times 2. Right side times 2. And let's see what happens. Well, 10.5 doubled. 10 times 10, or 10 times 2 is 20, plus the extra $1. I think this will be 21. On the left side, the 2 will distribute to this guy and to this one. Well, 5 becomes 10. When I distribute to this one, though, the dividing by 2 will cancel the multiplying by 2 and leave me with negative 1 times x minus 7. And I like that a little bit more than having to deal with the decimals and fractions up above. Now let's just follow SADMEP to finish our last problem for the day. Negative 1 distributes. Negative 1x. Negative times a negative is a positive. Combine your like terms. I see 7 and 10. 7 and 10, of course, makes 17. And then we finish solving. Let's undo adding 17. This is the SADMET part by subtracting 17. Negative 1x equals 21 minus 17. That's 4. And then we divide. Anything divided by itself makes 1. And we end up with x equals, well, anything divided by 1 is itself, but a positive divided by a negative is a negative. And we're set. Whew. What did you need to get out of today? Ultimately, you needed to be comfortable with the 9 problems on the first page and the fact that there are 3 steps to solving equations. Step 1 is you look for that distributive property. Those are parentheses. Step 2 is you want to combine like terms. And then step 3 is you follow SADMEP to isolate x. And that's it. Those are the same 3 steps we're going to see day in and day out, not just in Algebra 1, Unit 1, but in every unit we do, and in geometry, and in Algebra 2, in any math class. Those are the important big 3 steps. Distribute, combine like terms, SADMEP. So thank you for hanging out with me. I hope you got a lot out of today. Practice, practice, practice. Please let me know if I made any mistakes. I'm happy to correct them, and I will see you back next class for lesson 1.3.